In this video, we're going to learn how to use synthetic division, which is a different form of polynomial long division, but specifically dealing with factors that are just a 1x plus or minus a number. Because something interesting happens whenever you just have a degree 1 x with a coefficient of 1 in division, where as you're dividing, that first coefficient you see here is the first coefficient of your answer, and the term is just 1 degree less. And as you continue to divide, what you get here after you subtracted, that -8 is part of the final answer as well. And then after you get your remainder, that's what pops up as your remainder. So it's a nice pattern that happens whenever it's just x by itself plus or minus a number. So let's see how to use synthetic division. So the way you do is, since we're subtracting every time, what we like to do is take the opposite of the sign from our linear factor. So meaning when I say reverse the sign, whatever sign is by x, you use the opposite sign. So plus 7 instead. And then you'll write the coefficients of what you're dividing by. So it'll be 3, -29, and then 56. The reason why I'm getting rid of all the x's is just to get rid of things to write. So I don't have to rewrite x over and over again. Now, because of the pattern here, because x is going into 3x squared, of course that coefficient is going to be carried with it to the answer. So your first step is actually just to drop the coefficient, and that's now part of your answer. And we're going to interpret this later in a very specific way. So 3, that's where that answer was. Now, to get to this 21, I would have multiplied -7 by 3 and then subtracted it from 29. But since I already took the opposite of 7, I'm going to do 7 times 3. So multiply the coefficient I just brought down by the divisor, 7 times 3, which gives me 21. And since I've already made this opposite, I don't have to worry about the double negative that makes it positive 21. It's already positive 21. And now I can just add to the next coefficient. So -29 plus 21 gives me -8, which was part of my answer as well. And again, I can now repeat that same process, multiply the coefficient by the divisor, 7 times -8 gives me -56, which before I would have had to subtract 56, but since I've already made this opposite, it made this opposite as well, so I can just add straight down. And that gives me 0. So now the way you interpret your answer here is, up top this was like 3x squared, 29x, and then 56 was the constant. You just go down by a degree, just like I talked about earlier. So now instead of x squared, this term down here would be the x term, the -8 would be the constant, and the last thing you get will always be the remainder after the constant. So when I'm interpreting this answer, I can just read it as 3x minus 8, just like I would have gotten before. So let's see this in practice. So here I have a cubic polynomial divided by the linear factor x plus 2. Again, very important that it's just x. If it's not, you have to use polynomial long division. But to set this up, I'm going to reverse the sign. So instead of a plus 2, I'm going to use a -2. And then I'm going to write down the coefficients of what I'm dividing by. So 1x cubed, -14x squared, 51x, and then -54. Now the thing to keep in mind is, as I go through this first term is not going to be an x cubed term in my answer. It's going to be an x squared term. And the next one's not going to be an x squared term. It's going to be an x term. And the next one's not going to be an x term. It's going to be a constant. And now instead of getting a constant here, the last thing is going to be the remainder. So again, first I'm going to drop the first coefficient. So that's right now my final answer already has a 1x squared. And then I'm going to do -2 times 1, which gives me -2. Then I'll add straight down, giving me -16. Then negative 2 times negative 16 gives me positive 32. And then I'll do 51 plus 32, which will be 83. And then negative 2 times 83 gives me negative 166. And then negative 54 plus negative 166 gives me negative 220. So my final answer when I write it will be 1x squared minus 16x plus 83, and then my remainder of negative 220, so I'll write minus 220 over my divisor, x plus 2. Now let's try this again, but now I have x minus 7. So again, the first step would be to reverse that sign. So I'm going to use a positive 7 instead. Then I'm going to write down my coefficients. You'll see here there's no x squared term, so I'm going to write 1 for the x cubed term, 0 for the x squared term, then negative 57 for the x term, and then 56 for the constant. So again, as a reminder, I'm going to write it down here. The first term normally is x cubed, so the answer, the first coefficient I get will go for x squared. The 0 is normally attached to an x squared, so right here I'll get an x term. For negative 57 was the x term, so now I'll get the constant under that column. And then underneath the constant column will be the remainder. So, first step, bring down the leading coefficient. So 1. Then 7 times 1 is 7. 0 plus 7 is 7. Then I'll multiply that coefficient by 7, which gives me 49. Negative 57 plus 49 is, I meant to put that in purple. Negative 57 plus 49 is negative 8. 7 times negative 8 is negative 56. And then 56 plus negative 56 is 0. So I get that nice remainder of 0, meaning x minus 7 is a factor of that cubic polynomial. So my answer would be x squared plus 7x minus 8. 1x squared plus 7x minus 8. So what's nice is I factored out x minus 7 by dividing by it. And if this could be factored, I could continue to factor it further. Now, if the polynomial x cubed plus x squared plus 11x plus 6 expresses the volume in cubic inches of a box, and the width is known as x plus 1 inches, what are the dimensions of the box? So just like I talked about earlier, I could use this division technique to factor. I'm going to show you how you can use it. So again, I know the width is x plus 1, so x plus 1 should be a factor of that polynomial. So I'll set this up as x plus 1, or I'll write it out, x cubed plus 6x squared plus 11x plus 6 divided by x plus 1. I'm going to use the reverse sign of plus 1, which is negative 1. Then I'll write my coefficients of 1, 6, 11, and 6. And for my final answer, it starts with x cubed. So as I go through my final answer here, it'll be x squared, then x, then the constant, then the remainder. So it starts off with lowering the leading coefficient. Then negative 1 times 1 is negative 1. Then 6 plus negative 1 is 5. Then negative 1 times 5 is negative 5. 11 plus negative 5 is 6. And then negative 1 times 6 is negative 6. And then 6 plus negative 6 is 0. So what I get is x squared plus 5x plus 6 when I divide these two. So what I can say now is that x cubed, when I go to factor, x cubed plus 6x squared plus 11x plus 6 can factor into x plus 1 times x squared plus 5x plus 6. Now, this is a quadratic that I can factor. Two numbers that multiply to 6 but add to 5. That is just x plus 2 times x plus 3. And now I have three factors multiplying, which normally when you want to find the volume, you would think length times width times height. And I already know that the width is x plus 1, so the other two dimensions should be x plus 2 and x plus 3. So the dimensions of the box will be, just to put the width in the middle, x plus 2 inches by x plus 1 inches by x plus 3 inches. So if I was given any value for x, I could find the volume of that box. And that is how you use synthetic division.